Hello, my name is Maria from mathmammoth.com. In this lesson, we're going to study how to simplify expressions. First, some terminology. A term is an expression that consists of numbers and/or variables that are multiplied. Let me give you some examples. This expression is a term because 5 and x are multiplied. This one is also y times a times c. Let's make it c squared even, because that's c times c. Everything is still multiplied, and then multiply it by -3. So that's a term. Here's one that is not a term. There's a plus, there's an addition, not a multiplication. So this is actually a sum of two terms. X by itself is a term, and y by itself is a term. So it's a sum of two terms. And then, what about this one? Here also we see two terms. 6y is a term, because it's multiplication, 6 times y. And then this one here, 2xy, that's a term. So this is two terms that are being subtracted. And then what about this one? X over 6, that's a division. Is it a multiplication also? Yes, it is. We can write it as a multiplication of a fraction times x. This is actually 1/6 times x. So x over 6 also is a term. Then let's look at a coefficient. That is a number by which we multiply a variable part in a term. So for example, we might have -6 times y. The -6 here is a coefficient. Also, 2 times a times c. 2 is the coefficient. Or you might also see it like this, x squared times 10. This is not as common. We would normally write it as 10 times x squared or 10x squared, like this. But the 10 here is the coefficient. And then a constant. A constant is just a single number as a term. For example, you might have 18. That would be a constant. But let me also show you an example. If we have an expression with several terms, 5x plus y squared plus 17. 17 is the constant. Okay? This could also be a fraction or a decimal. Say minus 2a plus 7b plus 0.2. 0.2 is the constant. And then, like terms are terms that have the same variable part. For example, 2x and 7x. Those are two terms and they are like terms. They have the same variable part, x. That means that we can combine them. We can add or subtract them. So if I add them, 2x plus 7x, I would get 9x. Another example, let's say we have 5a squared and 6a. Are these like terms? Do they have the same variable part? This time, no, because a squared is actually not the same as a. A squared is a times a. So therefore, if they were to be added, I cannot simplify this. It just stays as is. Okay, let's look at now some examples where we simplify an expression by combining like terms. 12x plus 5 minus 7x minus 2. Here, 12x and 7x are like terms, so we can do the subtraction in this case. 12x and then minus 7x. So 12x minus 7x gives us 5x. I can also combine the constants. Here's plus 5 minus 2, 5 minus 2, and that is 3, so plus 3. That is the expression simplified. This other one is 3y squared plus 11 minus 8y minus 6. Can you simplify it? First of all, these two terms with variable parts, they are not like terms. Y squared and y, they are not the same variable part, so we cannot do anything there. But there's two constants, 11 and then 6. And 6 is subtracted, so we can do 11 minus 6. In total, this becomes 3y squared minus 8y plus 5. And we customarily list the constant term last in these kind of expressions. Two more. Try to simplify this on your own first. This one here, if you notice, it's just multiplications. This is a single term. So we do not actually add or subtract any terms here. We can simplify by multiplying here b squared times b, and here's yet times 3 times b. So we actually have b multiplied by itself 4 times, so we get b to the 4th power. And then 3 times 2 is 6, times 3 is 18, times 10 is 180. 180 times b to the 4th power. This one here, there's b squared, a term with b squared again, but there's also a term with b and another term with b, so we can combine these. We can add the b and 3b. 3b squared does not change, nothing happens, and then we add the b and 3b, get 4b. Then we have plus 10 minus 2, so that becomes plus 8. Lastly, I wanted to look at just briefly as to the reason why we can add or subtract like terms. What does it actually come from? Well, it boils down to something you know, the distributive property. Remember? I'll give you one example. For example, if you had 2 times in parentheses x plus y, then this is 2 times x plus 2 times y. We distribute the multiplication by 2. But in this example here, we're going to look at the reason why 2x plus 6x can actually be written as 8x. 2x is 2 times x. But I can also write it the other way because multiplication is commutative, x times 2. And 6x, I can write it the other way, x times 6. And now notice there is the same factor, a common factor, x, in both terms. So we can put that in front, and then in parentheses put 2 plus 6, using the distributive property backwards, so to speak, or it's called factoring. And now here, 2 plus 6 is 8, right? So this is x times 8, or 8x. So that proves to us why we can actually add 2x plus 6x and get 8x. And I hope this was helpful. We're all done now.